Morning, everyone. Very good morning to all of you. I hope my voice is clearly audible to you. Yes. Okay, fine. Good morning to the best teacher. Thank you, Brijesh. Good morning, good morning, good morning, good morning, all of you. Once again, very good morning. Okay. Okay, fine. Yes. So yesterday we have been discussed about the moment of the wall. Based on the movement of the wall, when what happens when wall moves away from the backfill and towards the backfill. I told you when wall moves away from the backfill, that is nothing but the active state, and when wall moves towards the backfill, that is nothing but the passive state. So then we discussed about how to determine the active state pressure and passive state pressure. You know that when the wall moves away from the backfill, then the soil moves downward and shearing resistance is going to be upward. You know that. What is this? Yes. Soil moves downward, and shearing resistance is going to be upward. As the soil moves downward, this is shearing resistance offer resistance to the movement so that the lateral earth pressure acting on the wall decreases up to the maximum shearing resistance attained. So then it's going to be plastic equilibrium. So in the case of active state, as the lateral earth pressure decreases, that is going to be minor. And in the case of the passive, as the lateral earth pressure increases, that is going to be major. So then how to determine the Ka and Kp? See, these are very important assumptions is required. So as it is said that dry and cohesionless backfill. Now, coming to the conclusions, at the end of the conclusions, I told you there are three coefficients, K0, Ka and Kp. And out of all those coefficients, Ka is going to be very less and Kp is going to be very high, which means in order to reach the active state, the yield or the pressure required is very less. So which one attains easily? Active state. And which one attains slowly? Passive state. And in between is going to be at rest. So now, based upon this, let's see how the stresses are going to be varies. How the stresses are going to be varies in the case of cohesionless soils. So, stress variation in cohesionless soils, which means C is equals to 0. Stress variations in cohesionless soils are, which means C is equals to 0. Now, in that, first let's go with the Rankine's condition. A dry or moist backfill, dry or moist backfill. The meaning of dry or moist backfill is there is no water table, Nana. Moist means just a wet. So dry or moist backfill, there is no water table, which means there is no pore water pressure. If this is the retaining wall, yes. Now, if this is a retaining wall, what I am showing you is a retaining wall. And if this is the backfill surface, if this is the backfill surface, so where is a ground level. Now, let me copy this because I will be using this one later. Okay, so now let's take this is a retaining wall. So in this retaining wall, now let's say the height of the retaining wall as a h. If h is the height of the retaining wall, and whatever the height, let's say h is the height of retaining wall, and it is retaining a dry soil mass, which means gamma, and then only phi c is equals to 0, because I am taking which type of soil? Erosionless soil. Now, I need to know how the stresses are going to be varies. I need to know how the stresses are going to be varies. So I want a stress variation over here. So if this is the retaining wall, and whatever the soil mass on the back of retaining wall is known as a backfill. So this is a retaining wall, and whatever the soil on the back of the wall is known as a backfill. So if the backfill is a cohesionless, and if it is a dry or moist backfill, how the stresses are going to be varies, and how to find out the active pressure, how to find out the passive pressure, and all those things. Now let's see. So at first, let me take one at the top of wall. At the top of wall, one at top of wall. See, you know that active pressure means Ka into sigma V. Passive pressure means Kp into sigma V, where Ka is equals to 1 minus sine phi by 1 plus sine phi, and Kp is equals to 1 plus sine phi by 1 minus sine phi, or Ka is equals to Kp is equals to 1 by Ka also. You know all these things. Now, how we are going to find out the lateral stress means I'm not going to discuss about the vertical stress here. I'm going to discuss about the lateral stress. See, now I'm going to say this chapter number 14 is exact similar to chapter number 7. I hope you remember chapter number 7, effective stress concept. Yes. How to determine the vertical stress means total stress. Same thing. Water table is there, effect of surcharge is there, everything is same. Just the only change is in chapter number 7, we take vertical stress. In chapter number 14, we take the lateral stress, vertical stress and lateral stress. So what is this lateral stress? Active is going to be Ka into sigma V, passive is equals to Kp into sigma V. See this, how to determine sigma V, we learnt long back in chapter number 7. Now multiply with Ka. So wherever you want to find out the horizontal stress or lateral stress, first find out the vertical stress. So come on everybody, at the top of the wall, what is the vertical stress? Vertical stress is going to be 0. Just simply keep your palm. If I keep my palm at 1, can I feel any pressure? No. So vertical stress is going to be 0. Then what is PA? PA is equals to Ka into 0, which is going to be 0. PP is equals to Kp into 0, which is going to be 0. So at the top of the wall, there is no vertical stress, means can I feel any vertical stress over here? Can I feel any vertical stress? No. When there is no vertical stress, then there is no lateral stress also. So now coming to 2-2. 2-2 means at bottom of wall or base of wall. At bottom of wall or base of wall. Okay. Now come on. You please tell me what is vertical stress. First of all, I am writing the vertical stress. Now you see at the base of the wall, what is the vertical stress you can see? So what is the total height over here? H and gamma. So what is the total vertical stress? Gamma into H. If this is the total vertical stress, then what is the lateral stress over here? Then what is the lateral stress over here? PA is equals to Ka gamma H. PP is equals to Kp gamma into H. Now sigma V is equals to gamma into H. So once we find out the PA and the PP, then you are going to draw the distributions. Now let's see the distributions. See, I have find out the vertical stresses and the lateral earth pressures. Now let's draw the variations over here. First, active pressure. How the active pressure is going to be varies. And then similarly, passive pressure. And then similarly, passive pressure. So now, come on, you please tell me how the stresses are going to be varies. Now, let's see. At the top of the wall, what is earth pressure? 0. What is at the top of the wall? What is passive pressure? 0. But at the bottom, by the time you reach, so what is our vertical stress? Vertical stress is going to be same. Yes or no? But what is PA? Ka into gamma H. What is PP? Kp into gamma H. So now, if you see, whatever this value is going to be Ka into gamma H. And whatever this value is going to be Kp into gamma H. Mind it, my dear students, I told you yesterday, you know that Ka is less than Kp. So at the bottom, this is going to be Ka gamma H. And this is going to be Kp gamma H. And which is going to be more? Which value is going to be more? So yet 1-1, whatever the self weight, is there any weight? See, just 1-1 is nothing but ground level, right? This 1-1 is nothing but a ground level, right? At ground level, is there any vertical stress? No, I'm not applying any external load over here. So it is going to be 0. So now you tell me, does Ka is more or Kp is more? Ka is going to be more than the Kp. So as you know, Ka is going to be more than Kp. See, I'm erasing this because you know all these values. What is Ka and Kp values? That Ka and Kp. Now, everybody have a look. This Ka and Kp depends upon whom? Phi. So Ka constant, Kp is going to be constant. And gamma is also going to be constant throughout the soil. Yes. Then what is the only varying? H. So now, so this is Ka into gamma H, Kp into gamma H. Just simply draw a line by joining those. So now you please observe whose magnitude is more. See, I am not drawing both the magnitudes as same. I am not drawing both the magnitudes as same. I am drawing active earth pressure magnitude is less because Ka is less than Kp. As you know, Ka less than Kp, then definitely active earth pressure will be less than the passive earth pressure. So I am showing you what is the passive earth pressure at the base. See, this variation represents at the top of the wall, active pressure is going to be 0. At the bottom of the wall, active pressure is going to be maximum. So, at the top, active pressure 0. At the base, active pressure is going to be maximum. Arey Baba, if you know the pressures, can't you find out the forces? See, if I know the pressure, can't I find out the force? What is the force? Area of pressure diagram is nothing but force. Area of pressure diagram is nothing but force. And where it is going to be act, sir? It is going to be act at the centroid, which means active force or active thrust. Centroid means from the base, it will act at a height of h by 3. From the base, it will act at a height of h by 3. Similarly, this is the passive pressure. So now, what is active pressure and what is passive pressure, sir? Active force or thrust. We can call it as active force or thrust. What is that? Active force or thrust. So Fa is nothing but area of PA diagram. That's it. What is the area of the PA diagram over here? Half into triangle, right? Half into base Ka gamma H into H. So then from this, Fa is equals to Ka gamma H square by 2. From this, Fa is equals to Ka gamma H square by 2. So now if I ask you, if I give you this condition, what is the active force acting on the wall? Is nothing but Fa is equals to Ka into gamma H square by 2. And mind it, do you know the length of the wall? Do you know the length of the wall? No. As we don't know the length of the wall, we are finding everything per unit meter. Per unit meter. You please look over the units of this one. What is the unit of the gamma? Kilonewton per meter cube. Yes, kilonewton per meter cube into h square, meter square. Kilonewton per meter cube into meter square. The units are going to be kilonewton per meter length of the wall. And now, similarly, passive force or thrust. So directly I can write as Fp is equals to Kp gamma H square by 2. I hope you people can understand here the difference between the active and passive is Ka and Kp only. The difference over here, if you observe whole, what I want you to make sure is the difference between the active and passive is just simply substitute Ka. And if you want to passive, instead of Ka, you substitute Kp. That's it. That's the only difference, nothing else. So This is about the conditions. Now, please go through this one. I'll give you. Okay. Yes. See the basic difference between the active pressure and passive pressure is simply this Ka and Kp. And you know that Ka is less than Kp, so Pa is less than Pp, and similarly Fa will be less than Fp. And some of the people are asking, sir, Fp should be opposite direction. Baba, what is mean by Fr, Fp? Active force exerted by soil and passive force exerted by the soil. Mind it, we are discussing about the soil pressure. This is a wall. If it moves, active. This is a wall. If it moves, this passive pressure is going to be increases. Okay, fine. Why the stretch diagram is triangular? Okay, fine, my dear students. You please observe this Ka depends upon whom? Phi. So as a Ka depends upon phi, for a given phi, K is going to be constant. For a given cell, gamma is also going to be constant. And the pressure depends upon whom? H. And as the H varies linearly, see at this point 1 meter, 2 meter, 3 meter. So then the pressure is going to be varies linearly. Yes. Okay. So I hope you understood this. This is going to be the case number 1, where I am just using the Rankine's principle. What is the Rankine's principle? Soil is dry and cohesionless. So now let's see the next condition. B, submerged backfill. Submerged backfill, which means effect of water table. Submerged backfill, effect of water table. Now, if you observe the submerged backfill, now in the case of the submerged backfill, again, you know the height of the backfill is going to be, height of the wall is going to be h, but this time I am going to provide you a water table. If I provide a water table, C anyway is 0 and phi, gamma becomes gamma sat. Gamma becomes gamma sat. Now you observe. Again, I am asking you how the stresses are going to be varies. My dear students, don't you think this is just like the chapter number 7 only? In the chapter number 7 also, the vertical stress variation is also going to be same, right? And the lateral stress variation also same. But the difference between vertical and lateral is this K. If you multiply K with a vertical, then it is going to be lateral. Ka multiplication gives active. Kp multiplication gives passive. K0 multiplication gives at rest. So now you see C0. So this time again 1 1 yet top of wall sigma V 0 PA and PP is equals to 0. You know that very well. Now yet 2 2 yet 2 2 means yet base of wall, yet base of wall. So now if you observe, yes, at the base of wall. Now what is vertical stress? Come on, see, whatever you are saying is nothing but vertical stress means total stress only. What is the total stress, Nana, we are going to get over here? The total stress we are going to get over here is a gamma sat into H. Gamma sat into H, because that's going to be fully saturated, right? And when it is below the water table, it's submerged also. Now, my dear students, can I write the total stress as effective stress plus pore water pressure? Yes. So can I write this gamma sat as gamma dash plus gamma W into H? Gamma dash plus gamma W into H, which means gamma dash into H plus gamma W into H. Okay. Gamma dash into H plus gamma W into H. So now you please say one thing over here. What happens to the gamma W into H? What is gamma W into H? Please tell me. What is this gamma W into H? This gamma W into H is a hydrostatic pressure. Hydrostatic pressure. See, as hydrostatic pressure is same in all directions according to Pascal. According to Pascal, you know that is same in all the directions. Yes or no? See, if I take the element due to hydrostatic pressure, if it is vertical as gamma W into H and horizontal is also going to be gamma W into H. Yes or no? So what is the meaning of hydrostatic case? What is the meaning of hydrostatic condition? What is the meaning of the hydrostatic condition? So the meaning of hydrostatic condition is stress is same in all the directions. Stress is same in all the directions. So when the stress, vertical stress, and this is going to be lateral stress. So as hydrostatic pressure is same in all the directions. Now what I am going to say is Ka is not multiplied. Ka and AP are not multiplied to gamma W into H. So keep that in your mind. Ka and Kp are not going to be multiplied to gamma W into H. Why, sir? Sir, this pressure is going to be vertical, sir, gamma W into H, sir. In the lateral direction also, as it is a hydrostatic pressure. What is the meaning of hydrostatic pressure? Pressure is the same in all the directions. Hydrostatic pressure, vertical, gamma W into H. lateral also it is going to be gamma W into H. So now please tell me, what is the active pressure? What is active pressure? Ka into gamma dash into H plus gamma W into H. What is PP? Kp into gamma dash into H plus gamma W into H. So I hope you understood what I want to say over here. So what is the point? See, in the case of the dry or moist, there is no water pressure. So directly we applied the Ka value to the sigma V. But when there is a submerged backfill, what is the meaning of submerged backfill? Effect of water table. See, I told you if a soil is submerged, then it must be saturated, right? Without a saturation, there is no submergence. Without saturation, there is no submergence. So gamma is going to be gamma sat. Then we can write the gamma sat as a gamma dash plus gamma W, because effective stress, you know, total stress is nothing but effective stress plus pore water pressure. So the point, my dear students, that you need to know here is this one. As hydrostatic pressure is same in all directions, K and Kp are not multiplied to gamma W into H. Keep that in your mind. So wherever there is a pore water pressure, I'm not going to multiply Ka and Kp for gamma W. I'll be multiplying only for gamma dash. Sir, now you tell me, sir, what is gamma dash, sir? Effective stress or total stress, sir? Effective stress. So I can write the point of Ka and Kp are applicable to effective stress only, not to the total stress. What is the total here? Gamma sat. And what is gamma sat? Effective gamma dash plus pore water pressure as gamma W. So gamma sat means only gamma dash, no sir, then why we added gamma W? Arey bhai, this type of questions if you are asking, I don't know whether you have attended the classes or not. What is this? Okay, fine, I want to go with the, you know that total stress is nothing but effective stress plus pore water pressure. Yes? Total stress means gamma sat into H, which is nothing but gamma dash into H plus gamma W into H. Yes? So what is this? This is nothing but effective stress. What is this? This is nothing but pore water pressure. As hydrostatic pressure is same in all directions, K and Kp are not applicable to the pore water pressure. It will be applicable only for the effective stress. Okay? Now I hope you understood. Sir, in chapter number 7, why we not included hydrostatic pressure? Look, see everybody. What is the meaning of hydrostatic pressure? The meaning of hydrostatic pressure is, stress is going to be same in all the directions. Hydrostatic. See, the meaning of hydrostatic is stress is going to be same in all the directions. So if the stress is going to be same in all the directions, if it is going to be vertical stress, now if the vertical stress is going to be gamma W into H, lateral stress is also going to be gamma W into H. So people might be present. This is a hydrostatic pressure. This is pore water pressure or hydrostatic pressure. I gave the name of pore water pressure as hydrostatic pressure in the earlier itself. Please tell K and KP what are they, sir? My head is, sir. What fall there, Rabbi? Please tell what is K and KP. Where were you people, yeah? From where you come? I have discussed this KA and KP how many times? Yes. See what is this? Without saying everything, I did not say. Without saying what is K naught and what is Ka over here, what is this Ka over here? Active pressure coefficient. What is Kp over here? Passive pressure coefficient. You see, passive coefficient. And what is this K naught, Ka, Kp? How many times I said K represents coefficient of lateral earth pressure, Ka active coefficient, Kp passive coefficient. Okay, fine. Now I don't want to get. Okay, I am from Telangana. Okay, fine. Some students would be there, just like I don't know. I feel like you means your parents might have a good amount of money so that they can spend on you. Hmm? If the classes were like as it is submerged, why didn't you take the effective stress at the bottom, sir? Sir, first of all, keep that one thing in your mind. I am telling you this vertical stress, vertical stress, vertical stress. Vertical means total stress, okay? And then I am going to convert that into effective stress plus pore water pressure. See, don't you think that there is a water over here and water cannot exert the lateral pressure? Don't you think that there is a solids, the solids will exert some lateral pressure, and due to solids, this is the lateral pressure, Ka into gamma dash into H, and due to water also there must be some lateral pressure on that. Water will exert vertical pressure and lateral pressure as same. So don't multiply K and Kp to the gamma W into H. Okay, fine. Next, go to the next point. So, in the case of the active pressure, in the case of the active pressure, now at the top 0. So whatever I have given at the top 0 and at the base gamma dash Ka gamma dash into H plus gamma W into H. So simply I can draw again. You please observe this is going to be a linear variation only. That's going to be linear variation only. Sir, why the linear variation again, sir? Sir, you see again here, sir, you say Ka is going to be common, sir. Means Ka, constant, gamma dash, constant, gamma W, constant. You take the H outside. If you take the H outside, then it is going to be linear, right? Then, what about PP? And from here, the PP see, I'm always showing you the magnitude of PP is going to be more. So now this value is going to be like Kp gamma dash into H plus gamma W into H. And whatever the force over here is nothing but Fa, and here it is going to be Fp. You know how to find out Fa and Fp? You just find yourself what is Fa and Fp. How to find out Fa and Fp? Once you draw the figure, what is the Fa and Fp? Just simply, you know, the area of the PA diagram is nothing but Fa, and area of the PP diagram is nothing but the Fp. See, my dear students, from now onwards, I am going to discuss only the active state, because you know the difference between the active state and passive state is a multiplication of Ka and Kp. Okay, done. If you have completed, then we go for the next one. Okay, so case number 1, I took a dry soil, and case number 2, I took a submerged soil mass. So if you have understood the case number 1 and case number 2, now let's combine both at the same time. Partially submerged backfill. I hope you can answer this one. Partially submerged backfill. Let's say there is a water table located. The total height is going to be H, and let's take the above depth is going to be Z1 and below depth is going to be Z2, and there is a water table located over here. Come on. There is a water table located over here. So now you please observe, hey, here C is equals to 0 and phi is going to be there, but above gamma, below it is going to be gamma. I want you to draw the distributions directly. So come on, you please tell me what happens over here. Okay. So now, if you observe over here, this is a partially submerged backfill. I am taking a above as a dry or moist backfill, below is going to be submerged. So just now I told you, see, can I go directly with the conclusions? Can I go directly with a pressure diagram PA? You please observe. So, okay, fine. At 1-1, vertical stress is going to be 0. So active pressure is going to be 0. See, I'm not going to find out the passive, because I told you passive means multiply with Kp. That's it. Instead of Ka, you see whatever the conditions we discussed so far. Instead of Ka, if I keep Kp, that is going to be Pp. So now I'm not going to discuss about the passive. Now you see, the practical examples I have already given, my dear. Please go through over here. I have given you the practical examples over here. So passive state can be seen in the active state, ordinary retaining walls and all those things. So if you are going to fill means on the back of the, yeah, you see this is a backfill, right? If it is going to be a partially submerged backfill, then how much pressure it is going to be exert? Then yet 2 to means yet water table. Yet a water table, what is the vertical stress? Gamma into Z1. So PA is going to be Ka into gamma Z1. And now you tell me yet 3 yet 3 which means base of wall. Come on. Yet 3 yet the base of wall. Can you please tell me, first of all, what is the vertical stress? First of all, what is the vertical stress? So everybody, you please observe what is the vertical stress over here. At first, at this point, can you please tell me the vertical stress, or I'll write this separately over here. At water table, vertical stress is going to be gamma into Z1. So active pressure is going to be Ka into gamma Z1. Okay. Now, yet 3 means base of wall. In the case of base of wall, now what is the vertical stress? First of all, you tell me what is the vertical stress. See, keep your palm and find out what is the total stress. See here, vertical stress means total stress. First, you write down the total stress, please. What is the total stress? Gamma Z1 plus gamma sat into Z2. And we can write this one as gamma Z1 plus gamma dash into Z2 plus gamma W into Z2. And you know, this gamma W into Z2 is known as hydrostatic pressure. And Ka and Kp are not going to be applicable for the hydrostatic pressure. So Ka and Kp are not applicable for the hydrostatic pressure. So then what is PA here is Ka into gamma Z1 plus gamma dash Z2 plus gamma W into Z2. So don't apply any Ka value for this one. Understood or not? For the gamma W into Z, don't apply any Ka value. So now if I draw the distribution, why you are considering the questionless, sir? Sir, just look. I took the condition itself as a questionless soil, sir. So that's the reason why I am using that. So now, let's see. So Ka into gamma Z1 plus gamma dash into Z2 plus gamma W into Z2. Now if you draw the pressure distribution, see, these many times I am drawing the pressure distribution, making sure that you are understanding the concept well or not. That's it. Okay. Now you observe at the top, what is the active pressure? 0. And yet 2, what is active pressure? Ka into gamma Z1. And yet the base, what is the passive pressure? What is the active pressure? Ka into gamma Z1 plus gamma dash Z2 plus gamma W into Z2. So now if I draw the variations, so from here to here, this varies like this. And now if you see, below due to water pressure, it is going to be more. Now you see, if you observe clearly over here, there is a small variation from here to here. Why? Because, so up to this point, this is going to be the value, and beyond this value, that whatever the value is going to be gamma W into Z2. So I don't want to create any ambiguity over here. So that's the reason why I'm not drawing any lines or in between, but you know that clearly here compared to this value, here gamma W comes into existence, right? So due to that gamma W, the variation is going to be more. So this is the stress variation. So I hope you understood. Why Ka is not applicable for the gamma W? You please go through this one. So okay, fine. I hope you understood this one. Now let's go for the next condition. D D. Now it is going to be surcharge on backfill. If there is a surcharge on the backfill, there is a surcharge on the backfill. So now you see this condition. So what about PP, sir? For PP, please, you just multiply with KP, then it is going to be PP, Nana. If you multiply KP, then it is going to be PP. Not, you don't need to worry about that, because instead of KA, if you multiply KP, that's going to be PP. I say this point a number of times. And now, if I am going to apply again, let's say the height of the wall is going to be H, C is still 0, 5, and now I take the moist backfill or dry backfill only, because I showed you the variation of the water table. Now I'm going to apply a surcharge. I'm going to apply a surcharge of Q. See, this time I am not going to go for at 11 or 22. I'm not going to go for at 11 or 22. I'll be writing directly. You please tell me. It's all about you people now. Now, after all this discussion, what is this PA? First of all, see, everywhere I am finding whom first? Vertical stress. Okay. At the top, now you tell me what is vertical stress. At the top, now you tell me what is vertical stress. What is the vertical stress I can feel at the top due to surcharge? I can feel a vertical stress of Q, right? So now what is PA? PA is nothing but KA into Q. That's it. That's it, as simple as that. See, when there is no surcharge, what is the vertical stress at top? 0. And what is the passive pressure, active pressure? 0. Similarly, passive pressure is also going to be Kp into Q. Yes or no? So now, I don't need to write down the PA, means a PP. Similarly, at bottom, what is sigma V? At the bottom, if you keep your palm, what is sigma V? At the bottom, if you keep your palm, what is sigma V? What is the vertical stress first? The vertical stress is going to be Q plus gamma into H. See, mind it, the total stress, total stress, total stress. Keep that in your mind. Total stress. What is total stress? Q plus gamma into H. Q plus okay, fine. Some of the people were asking, sir, how to determine the active force over here. I don't know how many doubts, why you are getting too many doubts today. So fine, let's take, this is going to be F1 and this is going to be F2. Okay. So in this case, the active force is going to be F1 plus F2. F1 plus F2. How to find out F1, sir? Half into base into height, sir. And how to find out this one, sir? Trapezoidal, sir. Trapezoidal. How to find out the trapezoidal area? I hope you know that. Trapezoidal area means, see, I don't want to make too much of complications over here. Once you draw the pressure distribution, the area of the pressure distribution is nothing but the force. Okay. So, yes, you can solve that. Now, what is sigma V? The sigma V is going to be Q plus gamma into H. Sigma V is going to be Q plus gamma into H. So the point over here is, look, due to the surcharge, chapter number 7, I explained you one point in chapter number 7. Due to surcharge at any depth, the increase in vertical stress is Q. The increase in vertical stress is going to be Q. Now, what is PA over here? Just apply KA into Q plus KA into gamma H. KA into Q plus KA into gamma H. So now, if you substitute those values over here, at the top and at bottom, at the top and at bottom, and in between, the variation is like this. So now, if you observe, yes, have a look at the top, Ka into Q, at the bottom, Ka into Q plus Ka gamma H. So now you see, at any depth you take, the increase in the lateral earth pressure is going to be how much? The increase in the lateral earth pressure is going to be how much? Ka into Q. So with this, I can conclude one point as, due to surcharge, the increase in earth pressure at any depth is K into Q. The increase in earth pressure. See, I am making an earth pressure over here. I am making the earth pressure over here. So in the case of the active state, there is a Ka into Q. In the case of passive state, that is going to be Kp into Q. See, the meaning of this one is, due to the surcharge at any depth, if you observe, The increase in the C, this is the condition number 1, right? This is the condition number 1, dry, right? Now, in the case of the dry or moist backfill, I have explained this one. Now you see, in the case of surcharge, what is this value? Ka into Q, Ka into Q. So have you seen the Ka into Q over here? No. If there is no surcharge at top, this is going to be 0, and at bottom it is going to be just simply Ka into gamma H, right? So now due to surcharge, at any depth you take, the increase in the earth pressure, is K into Q. If it is an active earth pressure, Ka into Q. If it is a passive earth pressure, Kp into Q. Active earth pressure, Ka into Q. Passive earth pressure, Kp into Q. And what about at rest, sir? K naught into Q, sir. What's there in it? Yet any depth is K Q. At any depth is K into Q. So due to surcharge, the increase in earth pressure at any depth is K into Q. If it is an active earth pressure, Ka into Q. Passive earth pressure, Kp into Q. Now, sir, what about PP, sir? Don't ask me the same thing with PP, because I told you for PP, Kp into Q. For PP, Kp, simply listen, in the case of cohesionless soils, if I write Pa, Ka into sigma V. If I write PP, just multiply, instead of Ka, you multiply with the PP. So wherever you see here, if I want PP over here, I can write Kp. If I want PP over here, I can write Kp. I hope you understood these points. So now, okay, now I hope you understood this. So if you have understood this, now let's see. Yes. Can we replace Ka, Kp with K naught? Yes. If it is an active state, then Ka, passive state Kp, and at rest K naught. You can go for K naught also. That's not an issue. So you can go through that also. Now, let's see the next conditions. First, I discussed about dry. Then I discussed about submerged. Then I have given you partially submerged. Then I have given you surcharge on the backfill. Okay. Now, the last one in this. See, every case I explained for whom? Cohesionless soils. You see, the common thing I made is C0, C0, C0. But sir, you are introducing the water table now. Why can't you introduce the C value, sir? Sir, you please go through the yesterday's. I have taken this entire, this Pa is equals to Ka into sigma V. How I got? By taking C is equals to 0, which means this Pa is going to be Ka into sigma V when C is equals to 0. And this is also going to be when C is equals to 0, passive. So whatever the explanation I have given so far is only for cohesionless. I did not give for cohesive. So wait for some time to get the cohesive. So first we complete the cohesionless. Now let's come to the next one. This is a very good and important one. So now In this, I am going to incorporate all the things. Wait and watch. Stratified or layered or anisotropic backfill. Stratified or layered or anisotropic backfill. So now you observe. Now let's take this as again a retaining wall, and now so here I am taking two different soils now. You please observe. So up to Z1, and this is Z2. Here phi 1. Here this is going to be phi 2. This is gamma 1. Here it is going to be gamma 2. Okay. So look, can I introduce all the conditions over here? I will be introducing all the conditions over here. Mr. Diven Raj, why we multiply Ka with such charge? Because such charge is same at any depth, sir. Sir, such charge is same at any depth. That is vertical stress, Nana. That is vertical stress. Due to such charge, the increase in vertical stress is Q, but the increase in lateral stress is going to be K into Q, because we are discussing about the lateral stresses, right? So now you come over here. See, this is a stratified depositor, means a two-layer depositor, Z1 and Z2. So now I will introduce all the topics over here so that you can understand much more better. I will introduce you surcharge. I will introduce you surcharge, and I'll give you a water table at the interface between the two soils, so that this gamma 2 is going to be whom? Gamma 2 is going to be gamma sand. So now let's see, everybody tell me how the stresses are going to be varies. So 1 1, 2 2, 3 3. Actually, I don't go for 1 1 2 2 3 3 for all these things. Directly I go for the pressure diagram. Can I go for the pressure diagram directly? Think. Can I go for the pressure diagram directly? Okay, fine. Okay, fine. Well, okay, I won't go with that directly, so don't worry. So this is 3 3. So now, if you see, I don't go for the direct. Most of the people are asking me. Fine, don't worry, because once we understand this in the questions, we can go for directly. So now, at top of wall, please tell me 1 1. See, whenever, if you have a doubt, you just go with the procedure. What is the vertical stress? Vertical stress is going to be Q. Then what is the active pressure? Ka into Q. That's it. Now, yet interface between two soils. Now, everybody listen to this condition. So everybody now, I just missed one point over here. So now if you observe, listen, see, this is the vertical stress, okay, and this is the lateral stress acting on the wall or not? Yes or no? So where we are taking the point over here, in the soil 1 or soil 2 at first? At the top of wall means we are taking the soil 1 or soil 2? Soil 1. So as I am taking, see, wherever I want to find out the stress, at that point only, whatever the Ka, that Ka you have to use. See, I am using a stratified deposit, right? When I use a stratified deposit, keep that in your mind. When I use a stratified deposit, yes. When I use a stratified deposit, now, wherever you want to find out the stress, see, this is the point where I am looking over the, I hope you people can be seeing this arrow mark I am showing you. This is the place where I want to find out the lateral earth pressure. What is the vertical stress Q? And this is the place where I want to find out lateral Ka. But how many soils are there here? Two soils are there. So let's say phi 1 is greater than phi 2. Phi 1 is greater than phi 2. You please just, I'll give you some common values of Ka. You please tell me. When phi 30 degrees, what is Ka value? 1 minus sine 30 by 1 plus sine 30. I am giving you some K values. See, these are the common values that you have to remember. This phi equals to 30 degrees because in most of the examinations, they will give you phi as 30 degrees. 1 minus sine 30. Sine 30 means 0.5. 1 minus 0.5, 0.5 by 1 plus 0.5, 1.5. 0.5 by 1.5, if you substitute, you will be getting 1 by 3. Phi is equals to 20 degrees. Ka, if you substitute, that is going to be 0.49. And when phi is equals to 0 degrees, you know, Ka is equals to 1. When phi is equals to 0 degrees, Ka is equals to 1. See, why, sir? You please observe, sir. That's going to be just like 1 minus sine 30 and 1 by 3. Now, everyone, please listen to these points. Yes. As you know, there are different phi values. For different phi values, different K value would be there. And if you observe over here, if the phi is going to be decreases or increases, you observe. If phi increases from 20 to 30, Ka value is going to be decreases from 0.49 to 0.33. Can I say when phi is going to be increases, then Ka value is going to be decreases or not? Think. When phi is going to be increases from 20 to 30 degrees, Ka value is going to be decreases. If I say phi 1 is greater than phi 2, then Ka1 is less than Ka2. Because I am taking a stratified deposit. What is meant by stratified deposits, sir? Layered, sir, are two different soils having two different phi values. So two different K values. Now, at the top of the wall, I am discussing about the soil 1. And this is going to be soil 2. So soil 1 means I have to write Ka1 into Q. Ka1 into Q. So now I hope you understood this point. Now, yet interface between soils. Which means 2, 2. Come on, please. First you explain me what is the vertical stress. Everybody, you please look over. See at this point, if I keep my palm, what is the vertical stress I can feel? Q plus gamma 1 Z1. Q plus gamma 1 Z1. See, this is the point that you need to remember very, very, very carefully. At the interface, what is the vertical stress I am going to feel? You tell me. What is the vertical stress I am going to feel? Q, that is going to be surcharge, plus, because due to surcharge, increase in vertical stress is same. So Q plus gamma 1 into Z1. Now, what about the lateral earth pressure, sir? Sir, you please look over here, sir. If this is the interface, sir, this is just above, sir, and this is going to be just below, sir. Sir, just above, what is the soil, sir? Soil 1. Just below, what is the soil? Soil 2. So now you tell me, at the interface, this is the vertical stress. Just above vertical stress, just below vertical stress, both are same. Just above and just below, vertical stresses both are going to be same. Vertical stresses are same. But what about lateral? Means active. What is PA? KA. Now just above, soil is KA1. Just below, soil is KA2, which means KA1 and KA2 are not the same. So we have to take, whenever there is an interface between the soils, you have to find out the lateral pressure just above and just below. So now just above interface. Now what is a PA? PA is just above, means KA1 into sigma V. What is sigma V? Q plus gamma 1 Z1. Okay. Q plus gamma 1 Z1. Now just below interface, just below the interface, what is a PA? PA is going to be just below the interface. This is going to be KA2, not KA1. KA2 into Q plus gamma 1 Z1. Sir, why you are writing again gamma 1 Z1, sir? Arre Baba, that is vertical stress. Keep that in your mind. First I am finding whom? Vertical stress. At interface between the soils, what is the vertical stress? Q plus gamma 1 Z1. And while I am discussing about lateral, there are different soils. Different soils means different Ka. Just above I have to use Ka1. Just below I have to use Ka2. So I hope you understood this point over here. So what is this? It is going to be gamma 1 Z1. That's it. You know Ka into sigma V. That's it. You know what is a PA? Ka into sigma V. That's it. Just above, what is Ka? Ka1. Just below, what is Ka? Ka2. And sigma V is going to be same, right? I hope you understood. Sir, why as coefficient of internal friction increases, active pressure decreases, sir? Sir, you please look over this value, sir. You can understand, sir. Please look over this value. When 530 degrees, what is Ka value? 1 by 3. When 520 degrees, what is Ka value? 0.49. Okay. So 0.49. So when phi is more, Ka is less. That's it. So now, last one. Yet bottom of wall, which means 3, 3. Come on, tell me what is the vertical stress now. Yes, you can see now the effect of water table also, right? What is the vertical stress? I will write directly now. What is the vertical stress? Q plus at this point, what is the vertical stress now? Q plus gamma 1 Z1, Q plus gamma 1 Z1 plus, this is a water table right now. As it is a water table, then I will write as a gamma 2 dash Z2 plus gamma W into Z2. Can I write like this? Because you know, below the water table, soil is going to be saturated. But you know that K is applicable only for the effective stresses, not for the pore water pressure. Yes. So now what is PA? See, now you see where I want to find out. I want to find out the stress over here. And am I in the second soil or first soil? Am I in the second soil or first soil? Second soil. See, keep that in your mind when you are using Ka, where you are using. Look, yet 1 I am using in soil 1, okay, Ka1. Yet interface just above Ka1, just below Ka2. Now 3 is in soil 2, so which means Ka2 into Q plus gamma 1 Z1 plus gamma 2 dash Z2 plus gamma W into Z2. So this is a 1 and this is a 2 and he's going to be 3. I hope you understood. So if you understood, now I'll draw the figure. I know you people will ask the same question. So sir, why we are taking just below interface Z1, but you took just below the interface Z is equals to Z2, but you took Z1 by sir. Sir, please sir, you observe the condition clearly, sir. Sir, what is mean by Z1, sir? The depth up to this point, sir. What is mean by Z2, sir? Z2 is the depth of the soil mass below, sir. Ka is a property, Z is the depth. You observe, you see what I have done over here. What is the vertical stress? At the interface, what is the vertical stress? Q plus gamma 1 Z1. Okay, fine. If I ask you find out the vertical stress over here, can you write Q plus gamma 1 Z1 plus gamma 2 Z2 or Q plus gamma 1 Z2? No, you don't write that. So my dear students, what I want to say at the end of this topic is, number one, whenever there is a layered deposit, you need to find out just above and just below. Just above and just below. Ka is going to be changed. Vertical stress is same, but the lateral stress is not going to be same. The lateral stress is going to be this. So the lateral stress is going to be like above Ka1, below Ka2. And if I take the point, it's going to be here. Wherever I want to find out, at that point, what is Ka? Here, at the bottom, that is going to be Ka2. So now, let's draw the pressure distribution. Once I complete, then I take a questions for this one. So now, At the top, what is PA value? At the top, the PA value is going to be at the top, the PA value is going to be Ka1 into Q. Why Ka1, sir? Because I am taking the soil 1, sir. Now, at the interface, so if you see just above, what is this value? Ka1. Just above Ka1 into Q plus gamma 1 Z1. This is just above. See, this is the interface, and just above Ka1 into Q plus gamma 1 Z1. Just below Ka2 into Q plus gamma 1 Z1. Because just above I am taking here Ka1, just below I am taking here Ka2, but the vertical stress is going to be same or not? What is meant by sigma V? Vertical stress. Are if you keep your palm at the interface, what is the vertical stress you can feel? Q plus gamma 1 Z1 only. If you keep your palm at the interface, you can feel Q plus gamma 1 Z1 only. Don't write it as please Q plus gamma 2 Z2. The meaning of gamma 2 Z2 is at this point, please. Now, coming to the last one. At the end. Now, this is the point where I am discussing, right? So, this point is in which soil? Soil 2, then Ka2. I can write directly Ka2 into top Q plus what is this? Gamma 1 Z1 plus, but below this is a water table, and you know that Ka, if there is a submerged, Ka is going to be applicable for submergence. Gamma 2 dash Z2 and plus gamma W into Z2. I hope you understood over here. So now I want to draw the pressure distribution. If you observe, let's say pi 1 greater than pi 2, then Ka1 is going to be less than Ka2. So now you see, as a Ka1 is going to be less than Ka2. Now if I draw the pressure variation, yes, first just above and just below Ka2 is going to be more or not? Now, this is how the variation is going to be, looks like. Yes. So just above Ka1, just above Ka1, just below Ka2 into Q plus gamma 1. So this is how the pressure distributions are. Why there is this gap, sir? You see above is going to be less value, sir. Below is going to be more value, sir. So just above is less, just below is more, because I took phi 1 greater than phi 2. So Ka1 is less and Ka2 is going to be more. So at first, the most important point that you need to worry about over here is this interface only. If you can understand this interface, then you can understand anything over here. So focus on the interface. Focus on the interface. What I have written, just above and just below. So these are the things that I want to mention. Now I'll be clearing your doubts because this is very, very important for the gate. Okay, meanwhile, you people go through. So now I'll have some doubts. So for KP, it would be reverse now. No, for KP, it won't be reverse. It will be KP1 and KP2 only. It won't be any reverse. Sir, can we combine and write KA1 and KA2 into vertical stress? No. Sir, if dry soil Ka is not possible, why? Who said that dry soil for dry soil Ka is not possible? Did I said that? Ka depends upon whom? Phi value, not the dry soil or saturated soil. So for two soils, K value changes. So why can't we use Ka1 for gamma 1 Z1 in 3,3? Are Baba, that Ka is a soil property. My dear students, I am telling you once again, Ka depends on phi value. And see, this is a soil property. And mind it, at the point 3, I am finding the stress at the point 3 means in soil 2. So at this point, what is Ka? The value is going to be Ka2. Don't write as a Ka1. Once again, wherever you want to find out the stress, at that point, whatever the Ka is there, you have to apply that Ka. If I ask you at the top, Ka1, at the interface just above Ka1, just below Ka2, wherever you take below the interface, Ka2. Sir, while finding lateral force at interface, then which one should we take? Sir, we don't consider the lateral force at the interface, sir. We do consider the force means area of the pressure distribution, Nana. Force means area of the pressure distribution. See, if they ask me the force, what is the total active force? I'll give you. I'll give you what is the total active force also. Please have a look. The total active force, now I'll take it as a F1, then I'll take it as a F2. Because see, for the first one, I'll take it as F1. For the first one, I'll take it as a F1 because this is there are two variations over here. So the first F1 is going to be the trapezoidal. Can't I say it as a trapezoid or not? This is nothing but a trapezoid, right? And this is also a trapezoid. So Fa is equals to F1 plus F2. Area of pressure distribution. Area of pressure distribution. So now first you find out F1, please. What is F1? Are Baba, trapezoidal area. The trapezoidal area means if I say this is a trapezoid, so if this is a H, this is small a and this is a small b, area of trapezium is equals to H by 2 into a plus b. Area of the trapezium is equals to H by 2 into a plus b. So now I hope you say now for F1, what is a? Small side. A means small side, B means large side, H means the difference between those, means the length or height. So now if you see this figure for the F1, what is this? This is Z1 and what is this? This is Z2. So can you please tell me what is the F1 now? F1 is going to be A, Ka1 into Q plus Ka1 into Q plus gamma 1 Z1 into Z1 by 2 into Z1 by 2. See, Ka1 into Q A plus Ka1 into Q plus gamma 1 Z1 B into Z1 by 2. Similarly, What is F2? Z2 by 2 into, now you see, what is F2? See, the above gone. Above is completed. Now what is below? The below is going to be Ka2 into Q plus gamma 1 Z1. See, Baba, please don't take Ka1 now because this is the second trapezoidal I am discussing over here. What is the second trapezoidal? Ka2 into Q plus gamma 1 Z1 plus what is the base? Ka2 into Q plus gamma 1 Z1 plus gamma 2 dash Z2 plus gamma W into Z2. So this is the forces. Then you can find out the force also. So force is not measured at the interface. Sir, if they ask the total active force, location, sir. Location at which total active force acts is x bar. Re baba centroid nana. F1 x1 plus F2 x2 by F1 plus F2. See, whatever from the base to here, this is nothing but x1. What about here? It is going to be x2. x2. So I'll write centroid for trapezium. You see here the centroid for the trapezium from the base. The centroid for trapezium is going to be b plus 2a by b plus a into h by 3. You see, if this is a trapezium, I'll write one more time. These are the basic maths, Nana. If this is a trapezoidal area having small side A, large side B, and thickness as h, so now the area is going to be h by 2 into a plus b, and centroid from the base, this is going to be x, b plus 2a by b plus a into h by 3. So you find out x2 and you find out x1, then you can find out these values. This is maths. This is a pure maths, just application of the maths. And don't worry, see, this is the highest complicated thing I have given you, because I introduced the surcharge, I introduced the water table, I introduced the layered deposit also. Whatever the discussion I made in the earlier 3 conditions, I have taken everything into the consideration. So my dear students, now let me recap quickly. The recap is, look, whenever there is a water table, apply Ka and Kp to the effective stresses only, because as a hydrostatic pressure is same, the Ka and Kp are not going to be multiplied to gamma W into H. And now, whenever there is a surcharge, and you know that due to surcharge, the increase in at pressure at any depth is going to be K into Q. And now, whenever there is an interface, you have to go with just above and just below. If you understood these points, then you can draw the pressure distribution for any question. I'm telling you, you can do it for any question also. So I hope you understood this. Sir, while finding lateral force, Sir, please tell for GATE people it's necessary to solve VSC questions. If you want to get good GATE rank, then you have to solve VSC questions also. Sir, Ka2 is less means, see, I told you that Ka1 is less than Ka2, no. Yes, my dear. See, sir, what if the phi1 is going to be less than phi2? Then Ka1 is more. Then this value is going to be more, and this value is going to be less. So, what's there? Sir, is Ka, yes, this is an assumption I take a Ka1 less than Ka2 because I took phi1 greater than phi2. Sir, how Ka2 you drawn as greater value, sir? Baba, phi1 is more than phi2, Nana. So, as a phi2, let's take phi1 as 30, phi2 as 20. So, for phi1, what is Ka1? 1 by 3. I discuss the same points continuously, and please go through the notes. So now let's solve a question so that you can understand much more clear. Yes. You see this question? Here is a classroom practice question. So see, if I say this one number, two number are there, all are classroom practice questions. If it is a GATE and IES, they will be GATE and IES over here. So if I represent the numbers, that is going to be classroom practice questions. So classroom practice question, CRPQ, a retaining wall of 7.5 meter high retains a cohesionless backfill. What is the type of cohesionless backfill? Means phi is equals to 0. The top 3 meters of fill has a unit weight of 18 and phi value as 30 degrees. And the rest has a unit weight of 24 and phi value as 20 degrees. Draw the active pressure distribution on the wall and find the total active force. Assume water table is at 3 meters depth. See, first of all, when they give you the data in the question for the retaining wall, you please drop down the data first. You please find out the data. Means you please draw the figure. Once you draw the figure, now the total height h is going to be 7.5 meters. So in that retains a cohesionless backfill, and in the first top 3 meters, yes. In first top 3 meters, you see the unit weight gamma 1 as 18 and phi 1 as 30 degrees. Gamma 1 as 18, phi 1 as 30 degrees. So now there is a water table located at the depth of 3 meters. and below the water table gamma sat, which means I'll write as a gamma 2. Gamma 2 is going to be how much? 24 kilonewton per meter cube. And what is phi 2 value? This is going to be 20 degrees. So now I hope you understood. Is it a layered deposit or same deposit? That is a layered deposit. See, this is a submerged condition with a layered deposit also. Okay, sorry. C0, not 50. Sorry. Mr. Kaushik, sir, why can't I take at the bottom Ka1? Nana, the Ka is a soil property. I'm telling again, the Ka is a soil property. So wherever you are going to find out, if you are finding a tree, you have to use at that point, whatever the soil are there, that point, that K you have to use. You are here. And what is here the soil phi 2? Then you have to use Ka2, not Ka1. Please stop your questions and understand this. So now I'm asking you, draw the active pressure distribution and water table at 3 meters. Take unit weight of the water, gamma W, as 10 kilonewton per meter cube. So now I'll be drawing. Now I'll be taking the distribution directly. Yes. So you understood, right? Now, for the students who wants a detailed procedure, yet to wall or at a top, sigma V is equals to 0. Then PA is also going to be 0. See, is there any surcharge? No. Now, yet interface. First of all, you tell me what is the vertical stress over here? Gamma 1 into 3, which is going to be 18 threes, 54 kilopascals. So just above the interface, then PA is equals to Ka1 into sigma V. Ka1 into sigma V. What is Ka1? See, given is phi 1 how much? 30 degrees. You know when phi 1 is going to be 30 degrees, Ka is going to be 1 by 3. When phi 2 is going to be 20 degrees, Ka2 is going to be 0.49. 0.49. So 1 by 3 into 54, which is going to be 18 kilopascals. 1 by 3 into 54, which is going to be 18 kilopascals. Now you see just below at the interface. See at the interface, just above and just below. Just above the lateral is going to be PA. Just above 18, and just below you have to take which is soil? Phi 2. Just above you have to take which is soil? Phi 1. So PA is equals to Ka2 into sigma V. Ka2 into sigma V. What is Ka2? 0.49 into 54. 26.46 kilopascals. 24.46 kilopascals. I hope everybody understood this point, because this is the one that you need to understand more. And now, yet bottom. So here you need to find out the vertical stress, and then you have to find out the what is the vertical stress over here? Please tell me. What is the vertical stress? Gamma 1 Z1. Let me write it. Gamma 1 into 3 plus, see, if it is 3, then the remaining is going to be 4.5 meters R plus gamma 2 dash into 4.5 plus gamma W into 4.5. And what is PA, sir? Sir, PA is going to be So what is PA, sir? Yet bottom of wall, you know that sigma V is nothing but gamma 1 into 3 plus gamma 2 dash into 4.5 plus gamma W into 4.5. Actually, there is gamma sat into 4.5. Now I split into two parts. You know that the Ka is applicable for gamma dash, not for the gamma W. So the PA is nothing but now Ka. Which Ka I have to use? Where I am asking at the base. So I have to use Ka2. Here, if I ask at this point, I have to use Ka1. So wherever I am asking you the point, the corresponding point Ka only we have to take, not the above or below. Wherever you are taking here. If I ask you here also, then I have to take Ka2 only. So Ka2 into gamma 1 into 3 plus gamma 2 dash into 4.5 plus gamma W into 4.5. Did they mention the gamma W here? Yes, 10. Now Ka2 0.49 into 18 into 3 plus what is gamma dash? 24 minus 10 into 4.5 plus 10 into 4.5. So can you please tell me the PA value here? So 14 into 4.5, 14 into 4.5 plus 54 into 0.49 plus 45. 102.33 kilopascals. So now I have everything. Just plot the points, every point. They're asking the active pressure distribution also. So active pressure, come on, you please tell me. At the top, pressure is going to be 0. Now at the interface, just above 18, just below 26.46, and at the base, what is the value? 102.33. At the base 102.33. Okay, so now I can draw the pressure distribution. See, this time the above is going to be less, below is going to be more. Why? Because they have given phi 1 30, phi 2 20, and you know that when phi 1 greater than phi 2, Ka1 is less than Ka2. What is Ka1? 1 by 3. What is Ka2? 0.49. So now just to simply draw the pressure distribution from here to here. First of all, this is the value 18, and then please observe. Now I'll erase this one. So come on everybody. Now let's say what are these values, please? So above, this is going to be above 18, and below what is this value? 26.46 below, and this is going to be above, and at the base it is going to be 102.33, and at top is going to be 0. See, I explained you the entire condition here. In fact, I took the what? Surcharge also. So here I did not take the surcharge. So this is a layered deposit. At first what I have done, let me go with the conclusion once again. At first what I have done is at the top, and at interface I am finding, and at the base also I am finding. Now, so once I know this one, see, find out the or draw the active pressure distribution on the wall. Yes. And find out the total active force. I need to find out the total active force. So for the total active force, this is F1 and this is F2. So now total active force, FA is going to be for the triangular distribution, for the trapezoidal distribution. For F1 over here, what is the triangular distribution? So what is this height? This height is going to be 3 meters. This is going to be 4.5 meters. So half into base into height. What is the triangle variation over here? Please tell me. Half into, what is the base? 18 into height. So half into base 18 into height as a 3 meters. So this is going to be 27 kilonewton per meter. So what is the meter, sir? Length of wall. So meter length of wall. Now what about F2, sir? What about F2, sir? Sir, I will convert this F2 as a rectangle and triangle, sir. It's up to you, sir. I don't want to go for that. I can give you one more way also. Then you can see I'm dividing into 3 parts. This is a triangle, this is a rectangle, and this is a triangle. But I know the area of the trapezoidal, so I don't need to go for the, in the gauge, don't divide much more parts. Above is going to be triangle, below is going to be trapezoidal. So now find out the F2. What is the area of F2? Small plus large into height by 2. 4.5 by 2 into, what is the small side? 26.46 plus, what is the larger side? 102.33. 102.33. So now you see here, now find out the F2 value, please. What is F2 value? 26.46 plus 102.33 into 4.5 by 2. I hope this value is going to be 289.77 kilonewton per meter. Yeah, this value is going to be correct only, right? 14 into 4.5 plus 18 into 3 into 0.49 plus 45. 14 into 4.5 plus 54 into 0.49 plus 45. Yes. So now what is the active force? Totally is going to be 27 plus 289.77 which is going to be 316.77 kilonewton per meter. So the final answer is going to be that value. So this constant notification ringtone of WhatsApp from your side. Okay. I'll remove that. Give me 1 minute. So now I hope you 316.77. I hope you understood. Yes, if you have understood this one now. Okay, if you want find location also, I will be including find location, find a location. So I am including one more part over here. I am asking you to find out the location also. So for the location, this is x1 and here it is going to be x2. So first of all, x1 is going to be, what is the total height? 4.5 plus, you see, for x1, 4.5 up to this point, and this is going to be h by 3, right? From the base, the centroid is going to be h by 3 for a triangle, plus 3 by 3, which is going to be 5.5 meters. And x2 is going to be, just now I mentioned you, here, centroid of the trapezoidal and centroid of the triangle is going to be h by 3 and centroid of the trapezium is going to be h by 3 into b plus 2a by b plus a. Now here x2 is going to be b plus 2a. What is b plus 2a? Here 1 or 2 point, x2 1 or 2.33 plus 26.46 by b plus 2a, 2 into 26.46 multiplied. What is the h value over here? For here, what is the h value? 4.5 by 3. So please find out this value. That's 26.46 by 102.33 plus 2 into 26.4 into 4.5 by 3. So it's going to be like 1.244 meters. Okay, sorry, b plus 2a by b plus a. I forgot about the formula. Please give me 1 minute. I forgot about the centroid. Once again, 1 minute, please. Yes, b plus 2a only. Yes, b plus 2a. B plus 2a, sorry, here it should not be. Yes. So 2 into 26.46, 26.46. Can you please tell me this value once? So 102.33 plus 2 into 26.46 by 102.33 plus 26.46 into 4.5 by 3. This is going to be 1.808 meters. So now the location x bar is equals to f1 x1 plus f2 x2 by total f1 plus f2. So 27 into 5.5 plus, please find it out. You please find it out and let me know the answer. 27 into 5.5 plus 316.77 into 1.808 by 27 into 5.5 plus 289.77 into 1.808 by 316.77. So the value is going to be like, I hope this value is 2.122 meters from base. From the base, you are going to find out the x bar. So x1, see, x1 is nothing but what is x1? Up to this height, what is x1? 4.5 plus this is going to be, what is this value? This value is going to be 3 by 3. That's right. See, with this I have included all the conditions. In the case of the cohesionless soil, not the cozy soil, but there are a lot of things to be discussed and we'll see for the break. Now let's have a break. So the time is 11:13 and 11:30, 11:30. So by sharp 11:30 I'll start today at no cost. And one more thing I want to say, today I have to conclude, today I have to end the session by 1:20 only. So I am not going to take any doubt clearing session today. I'll be continue the class up to 1:20 because I'll be complete this chapter today. See, we are going to complete the chapter number 14 earth pressure theories today. So I have to stop the class at any cost by 1:20 because from 1:30 onwards there was one more class, a mechanical class with the same ID. So management has told me that I have to stop the class by 1:30 and there is no doubt clearing session today. So I'll be giving you, I have created a Telegram channel. So you please go through that, the Telegram channel. You please search is online class. Geotech, all are caps. So that is there. Ace online class Geotech would be there. So yes, and link would be like if you find this also, you can get it done. So you please subscribe that so that whatever the questions you have, you please post into that. That will be like a discussion for the questions. So with that, what I can do is, see whatever the questions that the students have a doubts, the other student can clear the doubt also. I'll be monitoring that. So because there are other groups also, yes, civil group is there, but in that group all the people were there, all other subjects were there also. So what I did is I create one thing for geotech so that you can go through that. Yeah, you can write that. So I have given that. So whatever the questions you post, you can post, and other students can also reply for that. So I can give you the solutions for the questions most of the students are not getting, and remaining things that you people can discuss with yourself only. That will be more M4M discussion. So I prefer that you please go through this Telegram channel, and you can subscribe there. So now I'm giving you break. Come by 11. Okay, fine. Now, actually, there is a problem with the channel. So, there's a problem with the channel. You please follow everyone. I hope you might be already there. So, if you have been there, you please follow ACE Civil. ACE Civil. Please follow ACE Civil Telegram group. There was some problem occurred with this channel, so I deleted that. So you please follow the ACE Civil group and I'll be able to take doubt sessions from 7 p.m. to 8 p.m. 1 hour every day. So please follow ACE Civil. I'll be able to take doubt sessions from 7 a.m. to 7 p.m. to 8 p.m. every day for 1 hour. So the ACE link if you directly go to the ACE Civil, then you can get it there, I think so. Okay, fine. Not ACE Civil Academy, it's ACE Civil. So if you have been there, fine. But if you have not, then you please join there. So now let's go to the next discussion. See, whatever so far I have given you, everybody. Now let's start our discussion. Stop these things and I'll give you the link. I'll provide the link at the end of the PDF. So today, while I give the PDF, I'll provide the link of the ACE Civil group also. But now comes to the conditions. See, from the starting onwards, whatever I took, this is going to be a backfill is going to be horizontal or not? Yes or no? The backfill is going to be horizontal. Here also backfill is horizontal. Here also backfill is horizontal. And here also every condition I took, there is a backfill as a horizontal. So now let's come to the next condition. If backfill is inclined with horizontal. What if the backfill is going to be inclined with the horizontal? Now see in the same figure, what if instead of the backfill is going to be horizontal, now if I take backfill as inclined. So now you see this is a backfill which is going to be inclined. So backfill, inclined backfill, making an angle of beta. So where angle beta is an angle where beta is an angle made by the backfill with respect to the horizontal at beta. So now if this is the case, then how does the C, the same thing again, C0 and gamma is there, phi is there. How to determine the active earth pressure, passive earth pressure and all those things? See, in this case, the pressure distribution is going to be like, see, simply you go this first condition, here the pressure distribution at the base is going to be horizontal or not? Now, in this, what happens is, the pressure distribution at the base, the pressure distribution at the base is going to be exactly parallel to the slope. Is going to be exactly parallel to the slope. So now this is going to be the pressure distribution in the case of the inclined backfill, and you see this is going to be PA, which is going to be KA gamma H. And if it is going to be PP, KP gamma H. Okay. And you see here, so far, everywhere, if you observe, I have represented the force is going to be horizontal. Yes or no? The force is going to be horizontal. But in the case of the incline, this is going to be the force, and this active force will be acting at an angle with respect to beta. See, the simple point is when you raise the incline, when you raise the backfill with inclination, the pressure distribution is also going to be inclined everywhere, which is going to be exactly parallel to the, inclined horizon, means inclined. See, if beta is going to be 0, just simply tell me. See, this angle is also going to be beta. If I say beta is going to be 0, then the pressure distribution is going to be triangle with a base as a horizontal. And force FA is going to be horizontal. Yes or no? So, if there is no inclination, beta equals to 0, and if beta 0, this is going to be similar to condition number 1. This is beta 0. This is beta 0. Now, if I introduce a beta, then the change is going to be happening in the pressure distribution as it is going to be inclined. So now, in this case, what is Ka and Kp, sir? Here, Ka is equals to cos beta into cos beta minus root of cos square beta minus cos square phi by cos beta plus root of cos square beta minus cos square phi. So this is the Ka value. This is the Ka value. What is Ka value? Cos beta. See, this beta is going to be changes everything, right? Mind it, you don't need to worry about how the formula has been arrived. How the formula has been arrived, it is not important for your GATE or IES. So if the backfill is going to be inclined with the horizontal, then the Ka. Now, if I say there is no inclination, which means if beta is equals to 0, then what happens? If beta 0, cos 0, 1 into cos 0, 1 minus root of beta 0, cos square beta 1. You know that 1 minus cos square phi is nothing but sin square phi. If I say beta 0, cos beta 1, 1 minus cos square phi is nothing but sin square phi. And root of sin square phi is sin phi. 1 minus sin phi by cos beta 0, sorry, beta 0, cos beta 1 plus sin phi. 1 minus sin phi by 1 plus sin phi, that's the actual form of K. So, similarly, Kp is equals to cos beta into cos beta plus Kp is equals to cos beta into cos beta. Now you see here plus root of cos square beta minus cos square phi by cos beta minus root of cos square beta minus cos square phi. See, you simply observe the change over here. The change is going to be signs. The change is going to be signs. So here minus and plus, here plus and minus. So these are going to be the Ka and the Kp values, and then you can find out the Fa. Just that's nothing but area, half into base. What is base? Then Fa is equals to half Ka gamma h square. Fp is equals to half Kp gamma h square, and they are going to be act at what height? The height is going to be h at rate of h by 3 from base. See, the action is going to be at same height, h by 3 only. The action is going to be at the same height, h by 3 only. So this is the equation. So will h change? No. No, it's not 1 by cos beta, it is cos beta only. It's not 1 by cos beta. So it's not reverse. It's cos beta only. Now, let's come to the next thing. The very, very important thing. See, so far, I have discussed about whom? Cohesionless soils. So far, I was discussing about whom? Cohesionless soils. So in the cohesionless soils, we have been discussed so far. Now let's come to the cohesive soils. If there is a cohesion, now what happens? You know that Rankine says that soil is dry and cohesionless. And whatever the analysis I have made, this Pa is equals to Ka into sigma V, and this Pp is equals to Kp into sigma V is based upon whom? The Rankine's soil is cohesionless. Now, how it came? By taking C is equals to 0. So, now in the case of the R C5 soils, which means cohesion is present for C5 soils. Well modified Rankine's equation. Bell modified Bell is a scientist, modified the Rankine's equation. What he modified is, see, in the case of the C5 soils, so if you observe, sigma 1 is equals to sigma 3 tan square alpha f plus 2c tan alpha f. Earlier, we took C value 0. Now, I am not going to take C value as 0. So, I am going to take exactly whatever the C value is there. Now, in the case of active state, the minor principal stress is going to be, which is nothing but the active earth pressure. So now you put over here, please. If you do substitute, then sigma 1 as sigma V, sigma 3 as Pa, tan square plus 2c tan alpha. The same equation, here Just here sigma V is equals to PA. But here I am not taking C as a 0. Now I want this one. P tan square alpha F is equals to sigma V minus 2C tan alpha F. And I can write PA is equals to 1 by tan square alpha F into sigma V minus 2C by tan alpha F. So this is the equation. Now from Rankine, you know that Ka is nothing but 1 by tan square alpha F. And then root Ka is equals to 1 by tan alpha F. So now you substitute in this equation. Finally, the equation is going to be like Pa is equals to, you see, 1 by tan square alpha F as a Ka into sigma V minus 2C 1 by tan alpha F root Ka. Just as simple as that. I did not change much. I just introduce a C. When I introduce a C, the equation is going to be changes from Pa into Ka sigma V minus 2C root Ka. So now you see whatever the equation I got earlier is Pa into Pa is equals to Ka into sigma V. Now I am going to get Pa is equals to Ka into sigma V minus 2C root Ka. You please remember this equation only, because if there is no cohesion, C is going to be 0. For cohesionless, C 0. When C 0, Pa is equals to Ka into sigma V. And for cohesive soils, minus 2C root K. Similarly, let's apply the condition for passive. In the case of passive, you know the major is nothing but the horizontal, which is PP, and minor is going to be vertical. So PP is equals to, directly in this equation, PP is equals to tan square alpha F into sigma V plus 2C tan alpha F. Because you see, I'm just equating this equation from the plastic equilibrium equation. Now I can write this one as PP is equals to Kp into sigma V plus 2C root Kp. Because you know Kp is equals to tan square alpha F. So now the equations has been changed. Now the equation is going to be different for the passive and different for the active. So from this, what I want to conclude here is, so now you please observe, due to introduction of cohesion, the active earth pressure is going to be decreases. Due to introduction of the cohesion, active earth pressure is going to be decreases, and the passive earth pressure is going to be increases. You see, this is a plus and this is going to be minus. So due to cohesion, active earth pressure decreases by 2C root Ka, and passive earth pressure increases by 2C root Kb. So now I can write, due to cohesion, active earth pressure decreases, or I'll write decreases, and passive earth pressure increases. So compared to Pa is equals to Ka into sigma V, minus, decreases means minus, and passive earth pressure is going to be increases plus. So I hope now. So this is the conclusion point over here. So now I'll ask you, see, whatever the brackets I have kept so far, this is one of the ESE question, and they have asked one of the gate question from this also. And this is based upon the model of the previous ESE questions. This is based upon the model of the previous ESE question. They have asked a question based upon the surcharge. Wherever I keep the bracket, that is going to be very, 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 very important here. Everywhere, wherever is required, I am saying you important points. Now, let's see that effect also into the consideration. Why decreases, sir? Can you explain practically? Now I am going to decrease, sir. Explain practical, sir. Late, sir. Now, my dear students, now let's take into the consideration. So, I think can I draw here? Fine, fine. So I'll take a new tab. We'll go with a new tab. So in the new tab, I'll be explaining you. Now, what is the effect of the cohesion? And I'll write down back over here. So just to keep. So I'll be explaining you. Now, let's come to the next condition. See, I have taken some E, F, now effect of the cohesion. So C phi backfill. If there is a C and phi, now how the stresses are going to be varies? Okay, let's see. This is a condition where I'm going to mention you the height of the wall is going to be H, and this time C is there, phi is there, and gamma is there. Keep in your mind whatever the earlier conditions I made. This is a dry or moist backfill. Now I'm going to take the C phi backfill, which means cohesion is also going to be present. You know the effect of the water table, effect of surcharge and everything. Now there is a effect of the cohesion. So let's see what is the effect of cohesion over here. Everybody. So come on. You know, due to cohesion, what is PA? KA into sigma V minus 2C root KA. And what is PP? KB into sigma V plus 2C root K. Sir, I am not discussing about pure clay, sir. I am discussing about the C5 soil, sir. In the case of if I say pure clay, sir, then phi is going to be 0, sir. So now I'm just taking the effect of cohesion into the consideration. I'm not saying as cohesive, I'm saying C5 soil. So now, if you see, yet top of wall. Come on, tell me. At the top of wall, what is sigma V? 0, which means here at the top of the wall, sigma V 0. But do you think PA is going to be 0 now? Do you think PA is going to be 0 now? No. PA is going to be not 0. PA is minus 2C root KA. And what about PP, sir? 2c root Kp. So somebody has asked, sir, how the quotient is going to be decreased, sir? Now you see, sir, in the case of the quotientless, sir, what is Pa, sir, at the top? 0, sir. And now in this case, sir, minus 2c root Ka, sir. Sir, earlier, sir, 0. Now due to cohesion, does the value become minus or plus? Minus, which means active earth pressure decreased. And similarly, in the case of passive, at the top 0. And now, due to cohesion at the top plus 2c root Kp, which means passive pressure increases. Similarly, at bottom of the wall, at the bottom of the wall, sigma V is equals to gamma into H. Then what is Pa? Ka into sigma V minus 1. Ka into gamma H minus 2c root Ka. Just simply you find out that Pp. Kp into gamma H plus 2c root Kp. Okay. So now once we know the top and bottom, now I am going to draw the pressure distribution for active and passive. Active and passive state. Active state, active, passive state. So now let's draw the pressure distribution. Now, my dear students, come on, answer me. What is the active pressure at the top? Is it 0? No. Is it positive? No. Is it negative? No. Sorry, yes. In soils, you know that negative pressure represents due to tension. You know that clearly in chapter number 7 itself. I said you capillary pressure is a negative pore water pressure due to surface tension, their tensile force. And here also it is going to be negative, not due to surface tension, but due to some tension. So in the case of the soils, if I represent negative, then there is a tension. And you know that when it is a tension, we represent on the other side of the axis. Left side of the axis negative, right side is going to be positive. So now you see, what is this value now? This value is going to be 2c root Ka. I don't need to represent negative again over here because I have represented the arrow mark or not. Now, similarly, now at the base, what is the Pa value? At the base, Ka gamma H minus 2c root Ka. This is going to be negative and this is going to be positive. Negative and positive. Now, if I join a line by dropping from here to here, this is the active pressure distribution. This is the active pressure distribution. You see, the Ka is constant, gamma is constant, C is going to be constant. C constant, right? Phi constant, gamma constant. What is the only variable? H. So now you see this is a negative pressure and this is a positive pressure. This is a negative pressure. This is a positive pressure. First, let's draw the pressure distribution. So minus. Now let's come to the passive state. Let's come to the passive state. In the case of the passive state, at the top, what is the Pa value, Pp value? At the top, it is going to be like 2c root Kp. At the bottom, it is like Kp gamma H plus 2c root Kp. Now join these points. Now this is going to be the pressure distribution, which is going to be positive always. See, Now, my question for you, I don't have any problem with the passive condition. I don't have any problem with the passive condition. Why, sir? Because the passive state is almost equals to the surcharge case or not? The passive state is going to be almost equals to surcharge case. So how much surcharge is going to be present over here? Similarly, due to cohesion, this is the value that you are going to see increases. What is the value increases? The value is going to be increased by how much? 2c root Kp. 2c root Kp. Now the question is, if you observe, I don't have any problem with the passive state. I don't have any problem with the passive state. Now my question is all about discussing the active state. So I hope you understood up to this point. Okay. So now you see here, if you observe the negative means tension, which means let's say this is the depth up to which the pressure is going to be negative. Let's say this is the depth up to which pressure is going to be negative. Let's take it as a ZC. In this depth ZC, listen to me carefully, stop your thinkings and observe what I'm going to say. So up to ZC, the depth up to ZC, the pressure acting on the wall is going to be negative. If this is a wall and if the wall is going to be soil acts like this is a compressive. Yes or no? And what is the meaning of tension? If the soil tries to move away from the wall, then this is going to be the tension. Yes. So this is a wall. This is a wall. If the soil will compress, then that is going to be compression. But if the soil moves away from the wall, then it is going to be tension. Yes or no? So up to the depth ZC, whatever the soil mass, try to move away from the wall. So now, as it is trying to move away from the wall, it is going to be create some crack over here or not? You please observe. This is a soil mass. And as the soil is going to be tries to move away from the wall, this is going to be the tension. And if the soil is going to be moved towards the wall, that is going to be the compression. So now, due to this tension, negative means tension. See, don't get confused between capillarity and here. That is different. That is water. Capillary water is different. I'm just saying that in soil, pressure is negative means that is tension. Now, due to this tension, this soil will tries to move away from the wall. This soil will tries to move away from the wall, creating a crack, and this crack is known as tension crack. This crack is known as tension crack. So in this zone of ZC, the soil will try to move away from the wall, which means due to tension. And in this here, whatever the pressure is going to be compression. Whatever the pressure due to the soil is going to be compression. Positive means compression. Negative means tension. Due to this, a crack is going to be formed, and in this space there is a gap. And now you see, is there any contact between the soil and the wall here? No. Such a crack is known as tension crack. And the depth up to which this tension crack develops is known as a tensile crack depth. ZC is known as tensile crack depth. The depth up to which tension crack progress. the depth up to which the tension crack is going to be progress. So, my dear students, now the question is, see, I have drawn the pressure distribution. It's not a problem. The problem is, some of the students were asking me, in reality, if you observe, there is a crack at the top surface. You go over here, you see, if this wall, and if you can see it, where is it? If you can observe some crack over here, okay, fine. So if you observe over here, whatever the point, don't know why it is not working. Okay, fine. So if you see in the soil mass at the top, or in the soil mass at the top portion, if the soil is moves away from the wall, then you can see some crack. This is a wall, this is soil. You can see some crack. This crack is known as tension crack. So now my question is, if you observe, yes. So now, due to this tension, this cohesion is going to be moves the soil mass away. Now it is going to be forms a tension crack. So now the question is, up to what depth the tension is going to be developed? Up to what depth the tension is going to be developed? So let's see that. So now you know that yet Z is equals to ZC. Yet Z is equals to ZC. See, I took at the top of the wall, which means Z is equals to 0. At the bottom of the wall, which means Z is equals to H. Okay. Now I am asking you, yet Z is equals to ZC. Because I want the ZC value, yet Z is equals to ZC. Now, at this point, what is the vertical stress, please? What is the vertical stress? Gamma into ZC. Vertical stress is going to be gamma into ZC. And now you see the figure. What is the active earth pressure? You observe carefully. The condition I am going to use is, yet Z is equals to ZC, means at this depth, what is the active earth pressure is there? 0. Because up to this point negative, beyond this point is going to be positive. And what is tension crack depth? Depth up to which tension crack progress. So up to this point tension crack is there, and beyond this the pressure is compression. So due to compression there is no crack. Now yet Z is equals to ZC, whatever the pressure, this is nothing but the active pressure distribution or not. Active pressure is 0. And what is the vertical stress? The vertical stress is going to be gamma into ZC. Vertical stress is gamma into ZC, and active pressure is going to be 0. So now, what is active pressure, sir? PA is equals to KA into sigma V minus 2C root KA is equals to 0. So KA into, what is sigma V? Gamma into ZC minus 2C root KA is equals to 0. So now, you take to the other side, then Ka into gamma ZC is equals to 2C root Ka. You take gamma and Ka to the other side, then ZC is equals to 2C by gamma root Ka. Okay, so 2C. Now what is ZC? What is ZC value after all these conditions? So that ZC is going to be 2C by gamma root Ka. So now this is the tension crack depth. This is the tension crack depth. So my question for you people is, if there is a cohesion, due to cohesion, there is a tension at the top up to ZC. And what is the depth ZC? That ZC is equals to 2C by gamma root Ka, or you can write this one as ZC is equals to 2C by gamma tan alpha F, because you know that root K is nothing but 1 by tan alpha F, and 1 by root K means tan alpha F. So I can write it as 2C by gamma tan alpha F. I hope you understood this point. If it is a pure clay, pure clay means phi is equals to 0. Pure clay, phi 0, then what is Ka value, sir? When phi is equals to 0, 1 minus sine 0 by 1 plus sine 0, 1 by 1. So now the condition is, up to what depth there is a tension crack? 2C by gamma root K. So that's about the tension crack depth. Now let's see, you are an engineer. Array sir, then if I use the backfill as a C5 soil mass, so there is a tension crack up to ZC, and in order to remove this ZC, or in order to remove this tension crack, what I can do, sir? You just understand it clearly and think clearly. Array Baba, this is going to be in tension because the top pressure is going to be negative. Yes or no? As the top pressure is negative, then what I have to do? If I can reduce the negative pressure, then the tension crack is going to be decreases, and its tensile crack depth is also going to be decreases. Yes or no? So now, in order to reduce the tension crack, I have to reduce the negative pressure. How? By applying some surcharge. So now you see. By applying a surcharge of Q, okay, fine. Surcharge of Q. So now you see, let's go to the figure. If I apply some surcharge, if I apply some surcharge of Q, now this is a ZC depth, yet ZC, what is sigma V and what is PA? See, due to surcharge, then sigma V is equals to Q plus gamma into ZC. Sigma V is equals to Q plus gamma into ZC. Yes or no? So then if Q plus gamma into ZC, and what is PA value? PA is going to be 0. What is mean by ZC? The ZC is the depth at which the active pressure is going to be 0, or up to which there is a negative pressure. So now when I apply the PA 0, then Ka into sigma V is equals to 2C root Ka. Ka into sigma V is equals to 2C root Ka. See, I have written this 1 by root K, 1 by root Ka. Root Ka as 1 by tan alpha F, right? Then what is tan alpha F? What is tan alpha F? 1 by root Ka. So 1 by root Ka can be written as tan alpha F. So Ka into sigma V is equals to 2C root Ka. Now I can write sigma V is equals to 2C by root Ka. And what is sigma V? Now substitute. If I substitute over here, then Q plus gamma into ZC is nothing but 2C by root Ka. Send the Q outside, minus Q, gamma to the other side, then you can see this Q plus gamma into ZC. then this ZC is equals to 2C by gamma root Ka minus Q by gamma minus Q by gamma. So if you observe, yes, so minus Q by gamma, where this Q by gamma is going to be, yes. So now if you see, when I apply a surcharge of Q, then ZC is equals to 2C by gamma root Ka minus Q by gamma. So I hope you observe here, this is ZC and here this is ZC. So what happens to the tension crack depth due to application of surcharge? So if I apply a surcharge, then the tension zone is going to be decreases. Whatever this zone, this zone is known as the tension zone. So when you apply some surcharge, then positive pressure will nullify some negative pressure so that the tension zone will decrease. So the depth is going to be decreases. So can I say due to surcharge, critical depth means tension crack depth decreases by Q by gamma, decreases by Q by gamma. So this is the, see, these are the important things that you need to remember. If I apply surcharge, then what happens? If I apply surcharge, so ZC decreases by how much? So now you can ask me one more question. Are sir, you are saying if I apply the surcharge, you are saying that tension crack depth is going to be decreases. Now the question is, sir, when you apply surcharge, ZC decreases, right? Now if I don't want any tension, what is the surcharge I have to apply? Now the question is, for no tensile crack at all, for no tension crack at all, or for zero pressure at top, for zero pressure at top, for no tension crack at all, for zero pressure at top, the surcharge that should apply. So how much surcharge I have to apply is, so I'll explain you in both ways. First, so for no crack, see what is the meaning of a no crack? When there is no negative pressure, then there is no crack. So when you see, for no crack, ZC should be equals to 0. Now you take this equation here. When ZC is equals to 0, then Q by gamma is equals to 2C by gamma root Ka. Q by gamma is equals to 2C by gamma root Ka. Gamma gets cancelled, then Q is equals to 2C by root Ka. Then can I write this Q as directly this? You please observe, this gamma and this gamma will get cancelled. Then Q is equals to 2C. What is 1 by root Ka? 2C tan alpha F. Because 1 by root Ka means 2C tan alpha F. So if you apply this much amount of the surcharge, if you apply this much amount of the surcharge, then you can say there is no tension crack at all. Or I'll say for zero pressure at the top. For zero pressure at the top. See, I can give you one more way or one more explanation also. For no tension crack at all or for zero pressure at the top. Then you see PA is equals to 0, which means Ka into sigma is equals to 2C root Ka. 2C root Ka. And at the top, so you can write this is sigma V. So what is sigma V now? 2C for zero pressure for zero active pressure at the top. At the top, sigma V is equals to Q. Means you are going to apply some surcharge on that. This is at the top, right? For zero pressure at the top, so this is going to be Q. Now you can substitute this value as a Ka into Q is equals to 2C root Ka. Now you send this Ka to the other side. If you send Ka to the other side, 2C by root Ka or not, then here also Q is equals to 2C tan alpha F. So what I want to say here is, for no tension crack, see, these are the previous IS bits only. Whatever this one is, every bit I will show you in previous year. See how they have asked questions. They have asked tension crack depth, and they have asked if some certain intensity of surcharge is going to be applied, how much tension crack depth is going to be decreases, Q by gamma. And if you want to have no tension crack at all, I don't want any tension at all. If I don't want any tension at all, then what is the surcharge that you need to apply? 2C tan alpha F. And for zero active pressure at the top, then what is the surcharge I have to apply? So this is the conditions. I hope you people understood. Due to tension crack in backfill, what cause happened to the retaining wall? Wait, Nana, wait, I have not completed now. So just wait for that. So now, I hope you understood up to this point. So far, I explained you if there is a tension crack and up to what depth it exceeds, ZC. Now, if I apply some surcharge, how much tension crack depth decreases? Q by gamma. And what is the surcharge that you need to apply in order to remove the tension crack? 2C tan alpha F. Now let's see. Here, unsupported depth of excavation, or we can call it as critical height, HC. Unsupported depth of excavation or critical height, HC. So now, if you observe, what is the unsupported depth of excavation or critical height, sir? Now let's go back to the figure. So I will erase this. As you understand what is the meaning of the tension zone. So now, listen to me carefully. Listen to me carefully. You observe, what is this? ZC. This is ZC. And what is this? Negative. Now, can I say these are similar triangles to each other? As a negative and positive are similar triangles. Now, can I say, if I take up to one more ZC below, what is this? Positive. And what about here? ZC, negative. What about here? Positive. Are Baba, above negative, below positive, then what is the net active force? This pressure force means the area of this negative is a negative force and this positive is positive force. As the depth is going to be same, from the similar triangles, can I say, from the similar triangles, can I say, whatever this magnitude here and here both are same, but this is negative, this is going to be positive. My dear students, now you tell me, up to this 2 times of ZC, what is the net active force acting on the soil mass? 0. Why, sir? Here this is a negative force, sir. Here this is a positive force. So up to 2 times of ZC, the net active force is going to be 0. What is the meaning of net active force? 0. Sir, this is a wall, sir, and let's say up to ZC, I hope you can see the water level also. Yes. So I hope you can see the water level also, right? So now, if you observe the water level, so let's take this is the 2 times of ZC plus ZC. Up to this point, the active force is going to be 0, which means no lateral force is acting on the soil. When there is no lateral force acting on the soil, when there is no lateral force acting on the soil, then you don't need to provide any support. That is known as unsupported depth of excavation. So what is the meaning of unsupported depth of excavation? Is the depth up to which an excavation can progress without any lateral support is known as unsupported depth of excavation. The depth up to which an excavation can progress without any lateral support should has occurs when net active force is 0, which means when the active force is going to be 0, then only the depth up to which an excavation is going to be done. So now let's go back to the figure. Now, let's observe. Please have a look over here once. So now, this zone of ZC plus ZC. In the zone of ZC plus ZC, Now if you observe, whatever this force and whatever this force gets nullified. Yes or no? So this is a negative force and this is going to be the positive force. So the net force is going to be 0. Now, if I say this is a ground level, if I say this is a ground level, I can do the excavation maximum without any lateral support. You see, you observe, what is this ZC plus ZC? ZC plus ZC is going to be 2 times of ZC. So now, whatever this height is known as 2 times of ZC. So the depth up to which an excavation can progress without any lateral support occurs when net active force is going to be 0. You see, this is positive and you see this is negative. Then what is the net force in the 2 times of ZC? Active force in 2 times of ZC, depth is 0. I hope you understood. So whatever this and whatever this one, both the forces are going to be same. So I can say active force in these 2 depths, because this magnitude is also going to be 2c root Ka and this magnitude is also going to be 2c root Ka. So as both the magnitudes are going to be same and as the depths are going to be same, but one is negative, other one is positive, then the net force is going to be 0, and that is known as Hc is equals to 2 times of Zc. So keep that in your mind. Now, this Hc is equals to 2 times of Zc, and Hc is equals to, what is Zc please? 2c by gamma root Ka. 2 into 2c by gamma root Ka. So Hc is generally 4c by gamma root Ka. 4c by gamma root Ka. So yes. So what is the maximum depth that an excavation can be done without any lateral support? Lateral support means, have I provided any support over here? You please observe. Have I provided any support over here? This is a no support. No support is going to be provided. Yes. See, at the starting, I told you the soil natural angle slope made by the soil is going to be horizontal. The natural angle made by the soil with respect to horizontal. So this is the natural one. And now you see, in the case of the excavation, you see, you observe the clay soil mass. This is a clay soil or not clay? See this cohesion. If the C is going to be 0, come on, you please tell me. If C is equals to 0, what is critical height? 0, which means soil cannot stand vertical. So my dear students, I want to conclude one point over here. If there is no cohesion, then there is no critical height, then there is no unsupported, which means then there must be provided support. So in the case of clays, C5 soils are pure clays, the excavation can be done without any support up to some depth known as HC. So in cohesionless soils, then critical height is 0. In cohesionless soil, support must be provided. I can write for pure clay, phi is equals to 0, then Ka is equals to 1. Then what is HC? 4C by gamma. Sir, does it exhibits for the cohesionless soil? For pure cohesionless soils, C is equals to 0, then critical height is going to be 0, which means excavation cannot progress without support. What is the meaning of this? So the depth up to which excavation can progress without lateral support is HC. If HC is 0, then you cannot excavate without a lateral support in the case of pure positionless soils. If surcharge is applied, then if surcharge is going to be applied, then you know that when surcharge is going to be applied, what is ZC? 2C by gamma root Ka minus Q by gamma. ZC is 2C by gamma root Ka minus Q by gamma, and HC is equals to 2 times of ZC. See, why I said all these things is you don't remember blindly. You don't remember blindly. See, I gave you this one. If there is no surcharge, have I applied any surcharge over here? Have I applied any surcharge over here? No. But if I apply surcharge, just now I proved this is for normal case. And if you apply surcharge, then the tension crack depth is going to be decreases by Q by gamma. In examinations, the examiner tries to pull your leg. The examiner tries to pull your leg. You have done an excavation. You have done an excavation, and if a surcharge of some kilopascals is applied on the ground surface, if I apply some surcharge over here, then what is the critical height that you can provide it, or what is the unsupported depth of excavation? See, just you simply remember HC means 2 times of ZC. This is the basic. HC means 2 times of ZC. So now, in this case, when HC is going to be 2 times of ZC, as HC is going to be 2 times of ZC, if there is no surcharge, 4C by gamma root Ka. If there is a surcharge, you know that ZC is nothing but 2C by gamma root Ka minus Q by gamma. So my conclusion for you is, you remember HC as 2 times of ZC. You find out the ZC. You find out the ZC. Sir, how to find out ZC, sir? That ZC is going to be find out 2C by gamma root K. And sir, you can ask me, Arey sir, if there is a water table here, then can I use the same equation? No, 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 no. This is the ZC value for whom? For the C5 backfill. Is it a moist backfill or submerged backfill? Moist backfill. Is it a stratified or loose? Stratified. Sorry, loose. Normal deposit. Then how come I find out ZC at the time, sir? Use your mind. If you know, see, if you know the magnitudes over here, if you know the top magnitude and bottom magnitude, listen. If you know this magnitude and this magnitude, from similar triangles, can't you find it out? Yes, you can find it out. So that's all with this. And now the last thing, sir, what is the effect? Here there is no retaining wall. You don't need to provide any retaining wall over here. But the meaning of the support is, up to this depth there is no active pressure. There is no net force. So you don't need to provide any support. But if you want to go beyond HC, then you must have to provide the support. You see, observe here, up to this point, fine. But if you go beyond HC, this is ZC plus ZC, then the force is there. When there is a net force, then you have to provide the support. This is the support. Now the last one for this condition is active force. active force. Sir, how to find out the active force? Look, you know the active force means whatever the pressure distribution are not. So while you are finding the active force, there are two conditions. Before formation of crack. Before the formation of crack. This is for partial saturated soil and dry soil also, both will be there. But Baba, if for ZC, if surcharge is applied, ZC is going to be changes. ZC is going to be changes, but HC means 2 times of ZC. If ZC changes, obviously HC is going to be same. Okay. Or I can write this is for no surcharge. You know, ZC is equals to 2C by gamma root Ka when no surcharge. Okay. So now before the formation of crack, what is going to be happen? Before the formation of a crack. See, before the formation of the crack, total soil will be in contact with wall. Total soil will be in contact with the wall. See, before the formation of the tension crack, you observe that total soil will be in contact with the wall. When the total soil is in contact with the wall, then there is a negative pressure and there is a positive pressure. So you have to consider the tension zone. See, whatever you know, this is nothing but the tension zone or not? Yes or no? Then whatever the active force is nothing but let's take this as a negative force okay, let's take this as F dash and whatever this one as a F. So what is the active force over here? F minus F dash. Yes or no? F minus F dash. This is the active force. So here, what is F? How to find out F? You know that. You know how to find out the F? You know, this depth is going to be ZC. If this depth is going to be ZC, then what about this depth? This depth is going to be H minus ZC. So I am not going to solve this F and F dash because see, I don't want to solve this one because you observe here FA is equals to F minus F dash. See, you need to consider the whole. Total soil will be in contact with the wall. See, if you know the pressure distribution, then you can find out the F value directly. Half into base into height and half into base into height. But I don't know the pressure distribution right here. Do I know the pressure distribution? Means, do I know the values? No. So I don't consider. Now, after the formation of crack, after the formation of crack, once the crack is going to be formed, soil in tension zone will not be in contact with wall. So when the soil in the tension zone is not in the contact with the wall, now what we do is neglect tension zone. Neglect tension zone. So you need to neglect the tension zone. When you neglect the tension zone, please go to the figure once again. When I neglect the tension zone, then I have to consider this one only. Yes or no? I will be considering only this portion. So when I neglect the tension zone, see, after neglecting the tension zone, whatever the force so here, let's take this as FA1. Now, whatever this force, this is going to be the force. And let's take this one is going to be F, right? So here, in this case, FA2 is going to be F. When you neglect the tension zone, then FA2 is going to be F. So means when you neglect the tension zone, you remove the tension zone pressure. So now from this one, so can I write FA2 is equals to, see from this, can I write F is equals to FA1 plus F dash? So yes, you can write this. Now you see, what is this FA1? What is this FA1? Active force before formation of crack. Active force before formation of crack. FA2, active force after crack. So now can I write this FA2 is equals to, what is this F? FA1 plus F dash, which means now, my dear students, those who have asked what is the practical condition, sir? So due to cohesion, what is going to be happens to the active force? Due to cohesion, what is going to be happens to the active force over here? Now, you please tell me what happens to the active force, sir? So once the crack is going to be fully formed, after formation of the crack, FA2 is going to be FA1 plus F dash, which means active force increased by F dash. So what is this F dash, sir? Now let's find out the F dash. Let's find out the F dash. So you know this depth is going to be ZC. So F dash is equals to half into base 2c root Ka into, and you know that ZC is equals to 2c by gamma root Ka. So 2c by gamma root Ka. Just simply you know that F dash is equals to half into base into height. Yes or no? So half into base 2c root Ka into 2c by gamma root Ka. So now 2 gets cancelled, root K gets cancelled. Then what is F dash? 2c square by gamma. So now FA2 is equals to FA1 plus 2c square by gamma. So now I can write, after the formation of crack, after formation of crack, active force increases by 2c square by gamma. Active force increases by 2c square by gamma. And mind it, this is very, very important because in GATE 2018, they have asked a question based upon this. They have asked a question based upon this point. So what they have asked is they have given all the details and they asked what is the increase in the effective stress after the formation of tension crack. Once the tension crack is going to be formed, then what is the increase in the active force? The active force is going to be increases by 2c square by gamma. I'm telling you, once you start solving the GATE problems, you are going to get the beauty of these concepts. See, I'm taking much time to make sure to go from the root level to the top level. I'm giving you explanation for each and every point. So once the crack is going to be fully formed, soil in the tension zone will not be in contact with the wall. So you can neglect the tension zone. When you neglect the tension zone, then this is the only portion. This is the only portion. This is a tension zone. This is the tension zone. So this is the only portion. And what is this only portion over here? The only portion is going to be FA2, which is going to be F. And what is FA2? I can write FA2 is nothing but FA1 plus F dash. So now FA2 is equals to FA1 plus 2c square by gamma. I hope you understood the condition behind this. Are Baba, you don't need to go all these things also. What is this F? Is it negative pressure or positive pressure? Is it negative pressure or positive pressure? Negative pressure, right? When you remove the negative pressure, or if you remove the negative, means you are doing negative of the negative, then it will be positive or not. Negative pressure, if you remove the negative pressure, then the total pressure will increases. Yes, compared to before formation, after the formation, the active force increases by 2c square by gamma. So that's all with these conditions. Now, have a look. So that's the total. So what is the effect of the cohesion, sir? Active force increases, sir. Sir, when the active force increases, then the wall will be destabilizes quickly. When the active force increases, means the pressure exerted by the force exerted by the soil increases, wall will destabilizes quickly. So in the case of the clay soils, there is a possibility wall will get destabilized easily. I hope you understood the conditions, sir. So, but there will be a clockwise movement which may cause instability. Nana, it's not about clockwise movements over here. It's not about movements. It's about the net forces acting over here. So you are saying about couple. No, it's not couple. So this topic is clumsy. Yeah. What's there in clumsy there? Okay, fine. So I give you a quick review. Look, listen. The quick review I am going to give for the C5 backfill. Please listen to me carefully. In the case of the C5 backfill, means whenever the soil is going to be a cohesion is there. So if there is a cohesion, in the case of the cohesion, then what happens over here is so the active pressure is going to be decreases and passive pressure is going to be increases. So this is the equation. PA is equals to Ka into sigma V minus 2C root Ka. and Pp is equals to Kp into sigma v plus 20 Kp. And now coming to the conditions, now what I have done is at first I find out the top of wall and then bottom of wall, and I have drawn the pressure distribution, and from the pressure distribution I got to know the active state has a tension zone up to depth of ZC, up to depth of ZC. Sir, ZC, sir. So that ZC means at ZC what is the active pressure? 0. By using a top peak at ZC equals to ZC, active pressure is going to be 0. I have find out the tension crack depth as a 2C by gamma root Ka. So if there is a clay soil, then definitely the tension crack depth is going to be formed and it is going to be exerted up to a depth of 2C by gamma root Ka. And sir, if I don't want tension, sir, what happens due to this tension, sir? Now, just now I explained, Are Baba, due to this tension, formation of crack, the active force is going to be increases by 2c square by gamma. Yes or no? Active force increases by 2c square by gamma. Are sir, active force increases though, then definitely wall will destabilize, right? Yes. When active force increases, wall will fail. So in order to not to cause that fail, I am going to reduce that tension zone, means tension crack depth, by applying a surcharge. So if I apply surcharge, how much tension crack depth is going to be decreases? Q by gamma. Sir, you said very good, sir. So at first you said that clay, sir, and tension crack is there, sir. Once tension crack formed, then active force increased by 2c square by gamma. Now, if I want to reduce that, I'll apply the surcharge. So that tension crack depth will reduce by Q by gamma. Then, sir, I'll apply more surcharge so that I don't want any tension at all. Then what is the amount of surcharge you need to apply is nothing but Q is equals to 2C tan alpha F. So if I can apply this surcharge, then you see there is no formation of a crack at all. And there is no formation of this before formation or after formation. There is nothing like this. Okay. So, and then this is a unsupported depth of excavation. See, as you know, when there is a cohesion, in the top ZC negative, in the bottom ZC positive. And here the force is negative, here the force is positive. Then in this zone, the net active force is going to be 0. So what is the net active force is 0? If this is a wall, in the height of ZC, no pressure from the soil. Hare Baba, when there is no pressure from the soil, then you don't need to provide the wall. That is nothing but lateral support. Lateral support means wall. So I can go for up to HC, which is nothing but 2 times of ZC without any support. And that will be happen if and only if there is a cohesion. If there is no cohesion, then there is no unsupported depth of excavation. So normally HC is equals to 2 times of ZC. When there is no surcharge, HC is equals to 4C by gamma root Ka. And when there is a surcharge, then the ZC is 2C by gamma root Ka minus Q by gamma. Then you can write HC 2 times of ZC. So I hope you understood these conditions. That's about. Sir, in clay we have HC. Which soil is better than? Now you please. Now you only tell me, everybody. Now which soil is better? Cohesionless soil or cohesive soil? Cohesionless soil. Why, sir? Due to cohesion, the active force is going to be increases. Due to cohesion, active force is going to be increases. So now the best suitable backfill. The best suitable backfill. I hope you understood these conditions. So with this, so now I'll take this one, best suitable backfill. Now, if this is a retaining wall, and if this is a soil, then there must be some backfill. Yes or no? What is the best suitable backfill? So whatever this holes is nothing but the weep holes. I hope you have seen these holes. So for every wall, you can see this is nothing but the weep holes. You can observe there are holes at the end, so that whatever the water that comes over here, will passes through the weep holes. So now my question is, which one is the best suitable backfill? Which one is the best suitable backfill? Just now I mentioned you the due to cohesive soils, active force on walls increases. So it is better. So cohesionless soils are best suitable for backfill. And not only that, so in cohesionless soils, due to good drainability, what is meant by drainability, sir? Permeability. Due to good drainability, water can seeps through weep holes easily. So the best suitable backfill is going to be cohesionless soil, not the cohesive soil mass, because due to clay means cohesion comes. When the cohesion is going to be there, then the active force increases by 2c square by gamma. C means cohesion intercept. So in cohesionless soil, due to good drainability, permeability, water can seep through the weep holes, and these weep holes can reduce the hydrostatic pressure. See, when the water will passes into the weep holes, then whatever the hydrostatic pressure in the backfill will be decreased. Sir, what happens in the case of cohesive soils, sir? Sir, in the case of cohesive soils, does its permeability is going to be good or bad? Very, very poor. As a permeability of clay soil is going to be very poor, it won't allow the water to seep into the weep holes. If the water will not weep, then the density of the soil is going to be more. When the density of the soil is going to be more, it exerts a more pressure on the wall. So the best suitable backfill is going to be cohesionless soil. Understood? So I hope you understood these points. So everything is crystal clear, and I said you, if you go through the notes once again, you will be able to understand much more better. So don't worry about that. Now, still we have completed Rankine's theory. Still one more theory is there, Coulomb's theory. But Coulomb's theory is not important for the gate or IES. But we need to require about what are the points that we need to discuss. What are the assumptions made in the Coulomb that we'll be seeing tomorrow. For time being, see, I have explained you question number 1, right? I'm asking you, try it. Homework for you. I'll be sharing this one to you. Try it as a homework. So this is a homework for you. Question number 2. I'll be solving these questions tomorrow, because once we understand all the topics. Now, see, just a few questions of a ESC so that you can understand there is going to be. So just 10 minutes are there, 120. See, please, a few minutes so that you people can understand what is the importance of this logics I am saying. If you don't solve problems, then tomorrow definitely you will be missing those topics. So a retaining wall retains a sand strata of pi 30 degrees up to its top. If a uniform surcharge, what is uniform surcharge? Q, 12 ton per meter square, is put on sand strata, the increase in the lateral earth pressure intensity. The increase in the lateral earth pressure. See, ordinary retaining wall means active state. So you know that due to surcharge, increase in lateral pressure, which is nothing but delta PA is nothing but KA into Q. I told you clearly, if you apply surcharge, due to surcharge, the increase in earth pressure at any depth is going to be K into Q. So now phi 30 degrees, you know, when phi is equals to 30 degrees, Ka is equals to 1 by 3, 1 by 3 into 12, the answer is going to be 4 ton per meter square. 4 ton per meter square. So you can ask me, sir, why you did not take a passive pressure, sir? If you take passive pressure for phi 30 degrees, what is Kp? Tell me. Kp is going to be 1 by Ka, right? Then 3. Then 3 into 12, how much? 36. Is there any option of 36 over here? Is there any option of 36 over here? So if I say that is a retaining wall, mostly I'm telling you that is an active state. Okay. So the answer is going to be 4 ton per meter square. Answer is 4 ton per meter square. There won't be any options. Now, the notes will be uploaded. See, I will be uploaded the notes within no time, but I cannot go through the sessions. That's it. Earth pressure and resultant possibilities of wall movement are shown in figure. I have shown this figure also. So this x point and lateral moment of x point x. What is this x point represents? The x point represents, you know that highest point is going to be passive. The x point represents a passive earth pressure. Answer is going to be D. See, all these things are for the sake of you only, not for the sake of me. Now, yes, please look over. I want you people have a look over this question. Look, this is a list 1 and this is a list 2. In list 1, a masonry retaining wall founded on a compressible clay. So if a retaining wall founded on compressible clay, then as it is a compressible, settlement will occur. And wall moves away from backfill, which means, see, if this is a retaining wall which has been constructed on a clay, and this clay, it will undergo some settlement, right? Due to this settlement, then the wall may move away from the backfill. This is a wall. Wall will move away from the backfill and causes the active pressure. So in the list 1, I am giving you the type of structure, and in the list 2, what is the pressure exerted by the sandy backfill. This is a sandy backfill, and if you construct the structure on a clay soil, settlement will occur and wall move away from the backfill. So for the A, the answer is going to be active earth pressure 1. Now, pressure on back of cantilever sheet pile wall. I have explained you cantilever sheet pile wall. This is a sheet pile wall, and whatever this line is known as a dredge line. Whatever this line is known as dredge line. So now you know that this wall, you see, pressure on the back of a cantilever sheet pile wall near the embedment end. This is the embedment end, Nana. What is the pressure on the back of a retaining wall? Passive. So this is a cantilever retaining wall. So if there is a possibility, see, in the case of the clay, settlement will occur and wall moves away from the backfill. Then that is going to be the active state. What is the state? Active. And now you see the last one. So for B, this is going to be 3. A masonry retaining wall founded on rock. So now similarly, this is a sandy soil. Now it is founded on rock. Rock means no settlement, no movement. So when there is no settlement, no movement, this is going to be a trust condition. So for the masonry wall founded on rock, this is going to be 2. So 1, 3, 2, answer is going to be E. I have written these points clearly over here. You please observe. Okay, fine. As a lot of people are asking me to stop for today, I'll be ending the last question. This is the last question I am going to explain. This is the last one. Basement walls and bridge abutments are usually designed for at the pressure at rest. I told you at rest condition, basement walls and bridge abutments are going to be designed for at rest conditions. So assertion is true. Now, these are usually not restrained by the floor slab and by deck structure at their bases. I told you, go back over here, please. You see, this is going to be restricted by the base slab or not? Yes or no? So, in the case of at rest condition, the soil is going to be restricted by the base slab. But in the given question, what they mentioned is it is not restricted. No, they are restricted. So, which means in the basement walls and bridge abutments, they are restricted by the floor slab and deck structure so that no movement of the soil is going to be present. Sir, what is the meaning of a deck structure at the base, Nana? And so reason is not going to be true. So A is true, but R is false. Answer is C. These are some of the previous ESC questions. There are a lot of questions I have kept for you for explaining. So we're seeing those things tomorrow. Don't worry. I hope you people are enjoying the classes and I hope so. So now it's almost time. Tomorrow I'll be taking the doubt clearing session. So today I'll be ending the session as soon as possible. So I hope you people are enjoying the class and understood. I'm telling you, go through the notes once again, then you start. Then you will understand the things very clearly. Yes, so yeah, I'm closing this. I'm closing the session. You can leave because as I told you, by 1:30 there is a one more class, so I cannot take beyond this point. Mr. Sandeep Kumar, this chapter is full of confusion. No confusion. If you have not listened, then you get a confusion. You please go through the notes once again. You can get to know what is the meaning of that. Yes, I'll solve the gate questions also. I have kept questions for you. There are some gate questions. You see, there are a lot of gate questions I have kept. If you observe, this is a gate question, this is a gate question, this is a gate question. We'll seeing these questions tomorrow. So now I'll be leaving. I'll be sending the questions for you. I'll be sending the questions for you. Don't worry about that. So for today, I'm leaving the best for you. Please go through the notes once again. I'll be sending the questions today. Yes, I'm going to explain the Coulomb's theory tomorrow.